All right, let's start talking through this stuff. So inverse cosine, or they might also call it arc cosine, is used when we have a situation where it's like, so say we had something that was like cosine of theta is equal to like a half or something like that. If you have a situation where you need to solve this, before we had a degree amount, and we were looking for like one of the sides when it was just normal cosine, now what we would be doing is we would have two of the sides. So like if it was cosine, it would be the adjacent side over the hypotenuse, and we're trying to find the angle. So you would do the inverse cosine in a situation like this, and there's a button on your calculator that can kind of help you with that, but it's like the opposite, or like undoing what the normal cosine is. So definition of it there, so y is equal to cosine negative, or to the power, inverse cosine when it has that power of -1, x, if and only if x is equal to cosine y. So basically, you remember with inverses where they take the x and the y, put them in opposite positions. So like wherever the y was, the x switches to it. Wherever the x was, the y switches to it. And then they also say there that our y values are only going to go from 0 to pi, okay? And that's dealing like with this restricted domain stuff. So hopefully you got those pictures jotted down there from the book. So if they say something about like a restricted cosine function, this is the graph they're talking about here. So usually we know like our cosine function is going to be there, and it's going to like swoop down and then, keep going in like our up and down, graph, right? So with this restricted cosine function, a couple reasons they do this, and they kind of have them listed on the other page there if you flip back to it. But one thing they talk about is our values only going from 0 to pi, because what's pi equivalent to in degrees on our, yeah, 180, right? So if we think about it, I don't know why I was, unit circle, yes, that thing. So they do that because if we're talking about triangles, are we going to have angles that are bigger than 180? No, when we're on our triangles. So that's one reason they kind of do that too. Another thing they talk about, like I said on the previous page, they talk about all of our possible values, like highs and lows for our y's are included here, because your maximum there is at 1, your minimum is at -1, so all the possible y values you could have would be contained in that graph. And then with the inverse cosine stuff, what they're going to do is they're basically going to take your restricted cosine function, flip it over that y equals x line, so that y equals x line's cutting through the middle there, and then it's kind of go up like the other way with that. So another thing to think about here, why it has to be just that chunk of the graph. If we turned the whole cosine over and it kept, squiggling back and forth and then back and forth that way, would it still be a function if it squiggles like back and forth like that? You know what I'm talking about? Like if our zigzag pattern went up and down versus like right and left? No, because can we have like multiple x's when we do it, or like the vertical line test? If our squiggle went this way, would it pass the vertical line test? No, it wouldn't. So then it would no longer be a function. So that's another reason that they kind of cut it off like that. When you graph it on the calculator, it should also graph like that, where it's just like a little chunk of the graph for the inverse ones. And then you can also see there that our domain and range, since our x's and y's are switching spots, our domain and range also just switches around there to the opposite position. Okay, and then we'll just go to our example sheets. Everybody got an example sheet from yesterday? Okay. Okay, so the first one here wants us to evaluate the inverse of our cosine of -0.5 in radians, and it doesn't want us to use a calculator, okay? So my thought here would be, if they don't want us to use a calculator, we probably want to think along the lines of like a unit circle. So if I'm on my unit circle here, and I'm thinking cosine and -0.5, well, we know cosine stands for our x values, right? So wouldn't that be like us going over like -0.5 spaces to the left, and then turning that into like a little triangle there? 90 there. And then we're trying to figure out our radian value that would match that spot there. So if we're thinking our inverse of our cosine is -0.5 or -0.5, if we go back to our unit circle for where that would match up, I'm really too far in, what's that -1/2 on the cosine going to match with for radians? Yeah, the 2 pi over 3, right? So here, if they tell us our cosine or our inverse of our cosine is equal to a negative a half, we didn't need to know the degree amount. It'd be like 120 there. But if that's negative a half there for the cosine, the radian that pairs with that would be 2 pi over 3. So we would just write this as 2 pi over 3, because that would be in the same exact spot as the negative half in our cosines. Okay, so the next one here wants us to evaluate inverse cosine of that decimal number there to the nearest hundredth of a degree. When they say that, when it's like nearest hundredth, that's probably going to be something that's calculator-wise, so I would just straight up type that in my calculator. So if we do that, one thing we want to make sure of, since we're doing this in degrees, we want to make sure our mode is in degrees, so just double check that. And then I would just type this in just like it says here. So I'd go, so inverse cosine is above the cosine, so you have to go second, and then your cosine button. So inverse cosine second, and then your cosine. And then I would just type that number exactly how it has it there, so 0.99426. Hit enter. And it should give us our degree amount. Now, if you've got your thing set in radians, it's going to calculate it in radians instead of degrees. So make sure, because it's asking in degrees here, make sure we get it set to degrees. So that would be approximately 6.14, we'll just round to that, degrees. And like I said, if it's something like that, just use your calculator straight up on that. Okay, example 3 here. Does anyone know what this word is?
Proscenium.
What does it mean? Do you know? Proscenium?
Proscenium.
Well, I Googled it, but I didn't know what it meant. It's something with, like, theater and a stage. Like, what I got out of it is, like, if you have, like, a stage, it's, like, something with, like, the front part of a stage or something. I don't know. I don't think you need to really know about it, but you're propping something up to that, whatever. But you're propping it up on the back of a stage, and you have a board that's 9'6", who... You have a 9'6" board whose foot is 5'3" from the back of whatever that proscenium thing is. I think it's just like a wall thing or something you lean it up to. I don't know. And then what's the measure of the acute angle made by the board with the floor? Okay, so let's sketch this out so it makes a little bit more sense here. So we got our triangle. We know that the board we're propping up is 9'6". We know the foot is 5'3", so I assume the foot is probably this one going out this way here. From the back of whatever this thing is, what's the measure of the acute angle made by the board and the floor? So I assume that that's that angle there we're looking for. And again, on these, we're assuming that if this is some wall of some kind, that the wall's built correctly and it's at a 90. Okay, so when we're going through this here, we've got a hypotenuse and an adjacent side, right? So if we've got adjacent and hypotenuse, we know we got to go cosine for this. Different from the stuff from the other day, we don't have the angle here. That's what we're trying to find. So we set it up. It'll be cosine of theta, or whatever you put in there for your like angle. You could put an x or something in there as well. Is equal to, and it's going to be equal to our adjacent over our hypotenuse. Let's convert these to decimals from inches. 9'6". What's that in decimal? 9.5. So that'd be the same as 9.5 feet. What about 5'3"? 5.25. Yep. And if you weren't sure how to do that, basically you just take your inches and divide it by 12, because there's 12 inches in a foot, and that gets you to that 0.25. Same with the 6 and 12. 6 divided by 12 gets you that 0.5. Okay, so we'll put those in there. So we know it's adjacent over hypotenuse, so it would be 5.25 over 9.5. And then because we're looking for angle measure here, this is where we're going to use the inverse cosine, because we basically have to get theta by itself, we have to get rid of the cosine, so we need to do the inverse of it. So our theta would be equal to inverse cosine of that fraction. So 5.25 over 9.5. And then, like I said before, I'd just go straight into my calculator with this. And here we're trying to figure out the degree in our angle there, so we'll leave it in degrees. And we'll just go inverse cosine, and then I just type that fraction exactly as is. So 5.25 divided by 9.5. Put my parentheses around there, hit enter. and that should give me that my theta is approximately 56.45 degrees. So similar to yesterday, if you can get the triangle set up and the information you need, it's really not that bad to solve. And then there is one more thing I wanted to kind of add here. So it's not in our packets, but there's some questions on the assignment that's kind of set up like this. So I want to show you an example of it. So just jot this down. You can either do it in your little packet there, or you can just do it on your note sheet. I just added an example 4 to our stuff, just because there's one similar to that on the assignment. And I think even the worksheet too. Are you bored over there?
What?
This is very enlightening material.
Yeah.
How you can be bored. Okay, so like I said, I just wanted to add this question here because there's some on your assignment that asked something similar to this, so I just wanted to make sure we knew what was going on. So it says find 5 solutions to the nearest degree of cosine x is equal to 1/4 or a fourth. When we do this out here, so same concept as before, so you got cosine of x equal to 1/4. To solve for it, it would be like inverse cosine of that 1/4 is going to kick us out our x value. So to get one of those 5 solutions, we can just use our calculator straight up, right? So we can go cosine of, inverse cosine, sorry. Inverse cosine of 0.25 or 1/4, either way. And we get our number there, so like 75.52, whatever. I'm going to approximate that to 76 just to make our math a little bit easier here. You could do 75.5 or however, but we got to do some more calculations, so I'm just going to leave it as that. So that's one possible answer. Anytime you do it on the calculator, it's always going to give you the value between like 0 and 90 when it does it out, because that's just the way the calculator is programmed. But there are other answers that would be equivalent to this, that if we plug them in, we would get a fourth out. Like if we did cosine of, these other numbers we come up with, we'll still kick out a fourth. So what you want to think here is, going back to our unit circle, if I've got cosine of a fourth, or that would be like 0.25, that'd be over about that far, right? So our cosine is our x value, so somewhere right in there. Now, if you think about this, is that the only spot where it's cosine of a fourth? Where would it also be cosine of a fourth? On the bottom, right? So if we go out a quarter there, this one is kind of representing like our 76 degrees, kind of going out that way. But if we're thinking about like cosine values here, wouldn't our x be exactly the same down there? Wouldn't that still be cosine of a fourth down there? Yes, Ava?
Is this our other solution? I was going to write them in different colors.
Yes.
Okay.
The bottom one, yes. Okay, so it's a fourth up there, fourth down there, right? So here, if we're thinking about this and we're going this way, wouldn't those be like reflections of each other? Yeah, so if that went 76 degrees or about that way, what is it when we go clockwise around? Negative, right? So couldn't this represent like negative 76 degrees? Wouldn't that also be a solution? Yeah, so you could also have approximately negative 76 degrees. And then knowing what we know about unit circles, couldn't we also have those values like plus or minus 360? Because if we went a full 360 around and ended up at the same exact place, couldn't we get back to that location on our unit circle? Yeah, so you could take and you could do like 360 plus that 76 value, which would be 436. So that would be another option. They can all be in different colors, I guess. Okay, so that, you want me to circle them to let you know they're different answers? Yeah. Okay. Now could we do the same exact thing if we went backwards and just made another one like negative 436 degrees? Yeah. What if we go and instead of going this way with our negative 76 degrees, what if we start here and go this way? So like a positive number that ends up still down here. what would we do to find that one? 360 minus it, yeah. So if you did 360 minus that 76, that would also give you, what would that be? I got 284 degrees. That could also be a solution. Or you could have the negative version of that, any of those multiples like that. Now, technically, these are all approximations because we approximated it there, so technically there would be decimals and stuff with that there, but that's good enough. Now, what you can always do to kind of go back and double check this is instead of doing inverse cosine, you can just do regular cosine. So if you just did like cosine of that 75 whatever value, so like if I went second answer, it should kick me back to a quarter. Now, if you're trying it with these other values, so say you did like cosine of like 436, it's not going to be exactly 0.25 because we did some rounding there, but it should be pretty darn close to 0.25. So if you want to go back to check to see if these are right, you just put them in for cosine, and then whatever you kick out should be close to like the fraction you started with. Okay, make sense? Like I said, there's just a couple on the assignment that I wanted to make sure we kind of knew how to do those. But besides that, that's it for that section. Tomorrow's stuff is law of cosines, which I think, again, we should be able to handle pretty well. So working on that book page there, and we'll talk about it tomorrow.